Ms.C.Petchiammal, SFR College from Department of Microbiology. So today we are going to see about the topic is thin layer chromatography. So thin layer chromatography, so move on the learning objectives are introduction, principle and TLC technique, final application of thin layer chromatography. So introduction of TLC. So before move on the TLC introduction, what is TLC? So TLC is a important technique used for identification and separation of mixture of chemical compound into its individual components. So this chromatography consisting of two spaces, one mobile space, another one is stationary space. Mobile space or liquid content, stationary space or solid content. So difference in the interaction between the solid and stationary and mobile space enables separation. So next we are going to see about principle of TLC. So what is TLC techniques? Involve the distribution of components of a mixture into separate between two spaces. So two spaces are stationary and mobile space. Stationary space components of the mixture are partitioned between absorbents. So mobile space are solvents. So the two space between have different solubility and absorption of they are to be partitioned. TLC separation of the individual substance is based on their relative affinity towards stationary and mobile space. So the stationary and mobile space. So stationary space, it is a thin layer of absorbent coated on a plate. So usually silica gel, alumina, so whatever it is. So mobile space is developing liquid which flow through the stationary space carrying the sample. So stationary space between components with more affinity, so it travels slower, and then less affinity towards stationary space travel faster. So next, the RF value. RF means retention factors. So after result are represented by the RF value. So RF value is calculated as a distance travelled by the solute and divided by distance travelled by the solvent front. So next we are going to see TLC technique. So TLC techniques, that are three steps involved in this process. First step is preparation of slurry, and second one preparation of tank, third one application of sample. So preparation of slurry, so you should take plastic, glass or aluminum sheet is coated with thin layer of silica gel or alumina. So that is absorbent. So plates must be dried, activated and stored in desiccator until used. So second step, preparation of tank. So TLC tank was taken and clean and dry. The solvent mixture should be freshly prepared and the solvent poured down side on the tank. So maximum 1.5 centimeter depth on the side of TLC plate. The tank is covered with a glass lid and kept for the saturation. Third one is application. So application of sample. So the TLC chromatogram. So the next slide picture about the TLC experimental setup. You can see the next slide. So that is picture of experimental setup of TLC. So TLC is developed in a chamber which contains the mobile space. So when the mobile space rises up the plate by capillary action, the components dissolve in the solvent and move. So the first one is TLC plate, second one is TLC sample, third one is TLC chromatogram, final output of TLC sample. So the chromatogram of TLC plate was taken. So 1 centimeter from the bottom of TLC plate, so and a very small amount of sample was placed on the TLC plate. So after move on the mobile space, solvent and move, so dissolve the observe the result. So next, individual components in the sample move up at different rate. So polar analytes interact more strongly, so with the stationary space move very slowly. Non-polar analyte interact less strongly, so polar silicate gel more strongly, with the less polar mobile space, so higher up. So once the solvent reach at the top before 1 or 2 centimeter, so the TLC sheet plate was removed and developing chamber position and from marked. So, this picture or after completed the TLC techniques. So, the solvent is allowed to evaporate from the TLC sheet, so as the component is colorless. So, it can be visualized by suitable methods. So, any lipids content, so use the iodine vapor, amino acids, anhydrine reagent. So, also manganese activated zinc silicate. So, this is fluorescent component. It is added to the absorbent that allowed the visualization of spot under a black light UV. So, 254 lamp. One visible, the RF value of each spots can be determined. So, on this slide you can see the calculation of the RF value. So, different components are used in the TLC technique. Complete the process and note down the distance from the center of solute, spot the baseline and distance from solvent from the baseline. After noting down the reading, you can apply the RF value formula. So, that is all calculation of RF value, some example. So, that is all over the TLC experimental setup process. So, next we are going to see about application of TLC. So, what is application? So, this techniques is used in quality and quantitative analysis to separate organic compounds and to test the purity of compounds. This technique is useful for separation of lipid, amino acids, sugars and etc. So, it is useful in identification of components of a mixture and following the course of for a reaction and analyze the fraction collector during purification process and then purity of a compound. So, that is all application of TLC. Thank you for watching this video.